we're going to be getting into taking some notes on this stuff that we've been learning about. So we're going to be learning about states of matter. Last time you actually copied into your books the big picture of the states of matter, and we're going to go over a few details now. Here is a copy of that picture I told you about. If you've not copied that into your books, then it must be copied in now. Essentially, states of matter is the same substance but in a different state, so a solid, liquid or gas, or there are actually other states like plasma, but we won't go into that now. The next thing is that states of matter is easily reversible. So you can go from a solid to a liquid and then back to a solid again quite easily, and this simply involves giving or taking away energy from the particles. Now, what we're talking about is kinetic energy in the form of heat that heats up the particles, speeds them up, moves them from a solid into a liquid. Well, if you take that heat away from those particles and slow them down again, they're going to move back into a solid again. Now at this point in the video I want you to pause, because anything that's in red pen, you need to write those notes down in your notebook as part of your homework. So write these 3 notes about the states of matter down now, then we'll move on. It's important that you know the names of what we call the change in phase. Okay, this is the name for all the transition between the states. Some of these you do know very easily, some of them you don't. Most people will remember that going from a solid to a liquid, like butter going into melted butter, is melting. And most people know that going from a liquid to a gas is called boiling. Okay, the other name for that is evaporation. Coming back the other way, when you have a gas going down to a liquid, so if you held a glass on the top of your kettle as steam was coming out, water droplets would start to form on that glass because the steam is turning back into liquid water. We'd call that condensing, because the particles are being condensed or brought back together because we're sucking the energy out of them, slowing them down. Now, the next one is liquid to solid. We know this one pretty well. Liquid to solid is called freezing, or another word for it is called solidification. So here are those names that I said: melting, boiling, evaporation. Vaporization is another one of the words that you need to know. It's the same as evaporation. Condensation, going from gas back to a liquid. And freezing, going from liquid to a solid, is also known as solidification. Write those down in your books and add 2 more. Sublimation is where you go straight from a solid up to a gas. Now this can actually happen, and we see it happening quite often in real life and don't really think about it. Dry ice is a solid. It's actually solid CO2, the gas that we breathe out. It doesn't exist as a liquid. A very small amount of energy is required to turn it straight into a gas. So if you leave dry ice out, it will simply disappear. You won't see a liquid form of CO2. It just turns straight into a gas. There are other things in real life that do this. We know the little hard solids you have in your toilets that allow it to smell up nice. If you open them up, they simply go straight from a solid into a gas state to make your toilet smell nice. Iodine, graphite and naphthalene are other solids that sublime into a gas. Now if you turn it back the other way, going from gas straight to a solid, they skip the liquid phase. We call that deposition. I want you to write this picture down in your books. We're going to look at a few other things that we need to know about when it comes to changes of state, essentially mixing stuff up. Okay, when you mix something, that means you take one pure substance and add it to another pure substance, doesn't matter what those substances are, and you combine them. But notice here that there's no actual bonds holding these guys together. They can move around freely. They're not attached to each other, but they're mixed together, which makes it a little bit hard sometimes to pull them apart. An example of this is when you put all the ingredients together to make a cake. Once you mix them up, you've got Buckley's chance of pulling them apart unless you use some very sophisticated scientific techniques, and even then you're not going to easily do it. Now, a few things to remember with mixing substances. It can occur in both all of the solids, liquids and gases. Okay? So in a solid, you can mix dry ingredients together for a cake. Liquids, milk and water, gases. The air around us is actually a mix of a heap of gases, mostly nitrogen, but also oxygen and carbon dioxide, plus a few other gases, such as methane, because every time someone blows off, guess what? It actually mixes in the air around us. Just that after a little bit of time, it's so dilute you can't smell it. So we have a mix of ingredients around us most of the time. Most substances do not occur in their pure form. In fact, we have to spend a lot of money to take things back to their pure form. Most substances around us are actually found in mixes. When we dig iron out of the earth, we actually dig out iron ore. Okay, and we actually have to spend money to pull out the iron in that iron ore to bring it back to its pure form. The next thing we have to remember is this. Other types of mixing can happen, and we do this all the time. It's called dissolving. When you have a solid and put it into a liquid, if there is attraction between the particles in the solid and the liquid will actually pull apart the solid into its smallest possible pieces, so small that you can't see them. That's called dissolving, and that's a mix as well. So when you have a solid mixing with a liquid and dissolving, we call the solid part of that a solute, the liquid part a solvent, and together they become a solution, which is a mix of solid and liquid. This is like dissolving sugar in tea or salt in water. And we know that the solid is still a solid because if you boil that liquid and let it evaporate, you're still left with the solid that you mixed in there in the first place. So if you boil salt water dry, the water will leave and evaporate, but the salt won't, because it's essentially still a solid, but in a very small amount, in very small sized pieces. It hasn't turned into anything new. Water boils at 100 degrees. Table salt, however, requires a huge amount of heat, much more to actually melt it and then turn it into a gas. So it's going to stay in the bottom of your container while you boil off the water, because it's still, the salt is still a solid, even though you can't see it. So at this point in the video, I need you to pause again, and you need to copy out these notes, mixing substances. All of the notes that are in red must go in your book. Now the last part of this activity is you're going to be doing this learning object on your computers to play around and get a picture in your head of what solids, liquids and gases look like. So I'm going to get you to write down, go to that link in Connect there, and you're going to be going through the learning object. I'm going to take you through the first step so you can see how it's done, and the rest you will do yourself. So if we go over here, this is what it looks like on your computers. You click, I've already taken you through the kerosene one, then you click next, and it says, okay, pick an object to have a look at it up close. I'm going to pick the metal tap down here. This is an example of copper pipe, which is a metal, and copper is actually a pure metal, which means it's made out of one type of particle or atom. If we click the magnification here, it says, okay, this is what they look like. So here you have copper atoms. It's a solid, so they are stacked closely together. They are vibrating. They're not moving around, as you can see, and you have to tell it, give an answer here. Classify the arrangement. Are they close together and vibrating but held in position? Are they close together and free to move around? Or are they moving around quite fast? I'll pick that one. And it says correct. They're locked in a regular array. That's like a lattice or an organization. This gives the object a fixed shape and size. Now, you then have to put this in as a piece of evidence into what they call your findings. So you've got to sort everything out into particles that vibrate close together but are held in position, ones that move around slowly, ones that move around fast. So essentially solid, liquid and gas. When you add this to your sample, copper pipe goes in an example of the solids, which are vibrating but held in position. Close that, and now you have to pick another substance. So you need to work your way through all of these substances and have a look at them and complete that learning object.